Hello, Keith Rucker here at VintageMachinery.org. Guys, today I got another little project that I'm going to be working on for a friend, local person here in town that asked me if I could help them out with something. They've got a little buggy cart, whatever you want to call it. I think it's an Easy Go brand, kind of like a little golf cart type thing. I'm not exactly sure, but they've got an axle in it that the splines have stripped out on one end and it's just not working anymore. Unfortunately, the part is obsolete. It's an older unit and you can't order a new axle for this. So he asked me if I can make him one. And I said, yeah, don't see why not. So that's what we're gonna be working on today, is making a new axle. Now, it's fairly simple, basically. I'll show you up closer in a minute, but we just got a couple of ends on here, got some splines that have got to be cut. That's gonna probably be the biggest challenge to it, nothing we can't handle. I've got a hub here that actually will fit on this end of the shaft. It won't fit right now because this one's messed up, but I do have that we can test our spline fit with, and he's supposed to be getting me the piece that this end fits up in so that I can check that fit as well. But we're gonna get started on this today. We're not gonna get done with it, but we're gonna go ahead and get started. And what I really wanna do is get the lathe work done and just get this roughed out as far as, not roughed out, but finished out as far as the dimensions go, so that we'll be ready to go over to the milling machine and cut our splines. And that's gonna be done in an upcoming video. I gotta get the right cutters and stuff in to do this anyway. So let's show you what's going on with this, and we'll go get started on it, see if we can get this thing at least turned out today, get the turning done today so that we can move on with cutting splines later on. So this is the axle, pretty straightforward. This is the side that's kind of messed up down here. You can see where the threads are. It's stripped out here, and the splines are kind of stripped off right here. There's a little area there that something spun on it. Not exactly sure what happened, but not usable like it is. So got a thread on the end that tightens on that hub that I showed you a minute ago. This is where a bearing fits up on. This shaft part here, it's just there. I mean, this was roughly turned. It's not even really has any tolerances or anything on it. It just goes up in there. Down the other end, down here again, we've got a area, I think, where a bearing fits up on. I'm not sure. I think it's this surface that the bearing fits on. This one down here, I think, just fits up into a piece, and again, you got a spline down here. So anyway, we're gonna basically just copy this. Let's see, the length on this is 25 inches. The diameter, I remember it being an oddball size, so 1 inch, 1/875. So 1/875 is going to be 3/16. So 1 3/16 inch. I had to get some stock that was just a little bit oversized. I couldn't get 1 3/16, so this is 1 1/4. So we're gonna have to just roughly turn this down a little bit. And again, this is very coarsely turned on the original, not a critical measurement at all. What's critical is the ends down here with the splines and stuff are on it. So let's get started on this. I'm gonna start by getting a piece of bar cut to length, and we're gonna head over to the lathe and start doing it. I'm making this out of 4140. That's what the person I'm doing this for requested, so that's what we're going to be making it out of. And let's go see if we can get it done. Like so many of my projects, we're going to start over here at the marble saw, and we're going to cut a piece of stock off to length. So it's just going to be a little bit over so I can machine those ends down to size, but we'll just go ahead, and I got that marked where it needs to be. We'll let it cut across there. I think it's getting time for a new blade on this saw. That thing is not cutting straight at all, and that blade's just kind of wandering around. I think my blade is just getting dull. That's actually the blade that was on it when I got this saw. I have no idea how old it is. I've got a new blade up there. I just need to swap it out. Let's go to the lathe, and we'll go ahead and get started turning this thing out. We will start by facing this off and putting a center drill in the end. Come in with our center drill. Put a center in here. All right, let's flip it around, do the other side. Stock is small enough to go up through the headstock, which makes this a little bit easier. I'm going to go ahead and cut this to length or face it off, and then we'll get out my long calipers and we're going to have to get it cut to the right length. I don't know how critical that length is. We're going to get it as close as we can to that 25 inches. Should be just a little bit over right now. So let me go get my big calipers out and we'll check it. So I got my big 36-inch vernier calipers here, and I'm going to start by measuring the original shaft. Tape measure showed it about 25 inches, but you know, that's not a precision measurement by any means off a tape measure. And I'm looking at it, and right now it looks like it's just a shade under 25 inches, so we're about 20 thousandths undersized according to the vernier calipers. My guess is that this is supposed to be 20 inch or 25 inches. We're going to make it go shoot for the nominal. I'm sure there was a length tolerance, which is probably a pretty good tolerance on it. And I can already tell we're long here. Let's see where we are. So this is showing basically 150 thousandths over. So I need to get 150 thousandths off the length, and it just needs to be fairly close to 25 inches. I'll just take this back over there. I know how much to take off, so we'll just take off 150 and come back and measure it again, see how close we get. So I'm gonna come over, we're gonna just touch off on that. Right there, I'm gonna zero out my digital readout on the Z-axis, and we're just going to go in 150 thousandths. We'll just face it in. That's 150 thousandths according to the digital readout. I'm going to go ahead and put a center in there. Like before, we'll come in here and get this center in. This will let us put a live center in there to support it while we're turning it if we need it. All right, let's take it out. We'll go check that length, make sure we're where we need to be. I think we'll start working on our ends, or start turning down the diameter rather. All right, we're going to come back in here with our calipers. Sorry, I'm getting in front of the camera there, trying to stay out of your way. And we're shooting for 25. I'm looking for which line lines up the best. And I mean, it's right on 25.0. It may be a thou or two in one way or the other, but plenty close enough for what we're doing. So let's continue on. First things first, I need to take the outside diameter down to that 1 3/16. We're 1 1/4 inch right now. So basically a 1/16 of an inch needs to come off that. What is that? 62.5 thousandths. Not much at all. I'm gonna come in here and I think I'm just gonna do about a 40 thousandths pass, and then I'll get a good measurement off where we are. We'll come back and finish it up. So let's see. That's 20, 40, right there. This outside diameter here is not a critical measurement. It's just to give clearance. I imagine we're going to probably get some vibration on this. A little bit of chatter. Not going to matter. I'm not going to worry about surface finish on this at all. Looking at the original, it's pretty rough. So I'm just not even going to worry about it. We'll let it roll down through here. I'll come back and make a cleanup pass on the second pass once I kind of figure out where I'm at measurement-wise. And we'll get this down. Then we can start working on our ends, which is where the critical work is going to be at. I really wish that I had a follow rest for this lathe. The follow rest is similar to a steady rest. Of course, steady rest you put on here and it kind of gives it a support in a fixed place going down to the ways. A follow rest mounts to the carriage and basically just puts some support right behind the cutter. So as the cutter's moving, it's moving along with it. And that's really a good tool to eliminate any chatter, take that vibration out. They were usually standard equipment on machines as an accessory, but they weren't used that often. And unfortunately, it's hard to find an old lathe that still has those parts with it. I would love to find a steady rest for this one, but until then, we'll just make do. One day I may have to just make one. All right, we're approaching the end of our cut here. I got a line on there that just kind of gets me past beyond where we need to stop at. And I'm just going to go all the way back down to the end. I'm going to get in here and make a couple of measurements and figure out where we need to go to next. Five. I'm just going to take about 25 thou off. That'll be kind of an average. Take another pass. A little bit lighter than the last one. So I'm going to speed it up a little bit, go up to 1200 RPMs. Just make it go a little faster. Of course, I get a bird's nest within 1/8 of an inch of where I want to stop at. Come on. See if I can finish that out. And we were right there at it. That's it. Got a little vibration in it, particularly down on this end of the shaft. As we got closer to the support in the headstock, it diminished. And just checking my measurements, that's actually more uniform than the first pass. That one's all within about 3 thou. And that one's right on size. That's about 1 thou under. And that's about 2 thou under. But again, not a critical measurement, so I'm not worried about it. All right, we're going to start working on this end down here next. Let me get reset up. I'm just going to move the bar in. There's no reason to have the whole bar out. We'll have more support from the chuck closer up, and we'll just let the rest of it go up inside the headstock. So let's get set up for that. All right, I got my part in here ready to go. We're basically only going to be working on about 4 inches of this end, and I've got a little sketch here of what I need to do, not to scale, but I can work off of it. It'll give me something. I just went over there and measured the original shaft, and that's what we're going to be working on. I'm going to start by getting a 0 on my Z-axis on the link so I can kind of see how far I'm going in, and we'll just start turning our diameters in here to the lengths that they need to go until we get this thing to size. Let's get going. So again, I'm just going to touch off here on the end. Just barely touching there. I'm going to 0 out my digital readout. I'm going to go in 4 inches, which I can just read now right off of my DRO. Right there. I'm going to put a little visual line on there just so I know where I'm turning to. And the first diameter needs to be 0.985. 985, and we should be at, what did I say, this is 1875. So yeah, we've got about 100 thou to come off of there. A little less than that, but I'm just going to dial in 50 thou, make a pass, and we'll come back from there. So let me touch off. All right, that's roughly 50 according to my dial. Once I make this cut, I'll get that diameter put into my digital readout where we can work off of that. I need to change that insert. So I don't like the way that's tearing right there. Not good. Let me put in fresh insert in there. The finish is all right, but it's just kind of tearing that outside of the metal there instead of cutting it. All right, I've changed out that insert. Get this swarf out of there. And we are going back at it again. I'll get a measurement after this pass and we'll see where we are. Let's see where we're at. Use my micrometer. This is going to be a bearing fit, so I need to get this right on. And we're at 1 inch 27 thousandths. Put that in 1.027. Enter. And we're going to 0.985. Yeah, 985. So that's I'm just going to sneak up on this. Just going to do a 20 thousandths pass. This is a critical measurement on this one, so I want to get it right on. So we'll just take our time and sneak up on it. Let's get another measurement, confirm where we're at. All right, we're at 070. That's exactly what my DRO is saying, so I'm just going to dial it in to 985, and we'll go from there. Right there, 0.985. I'm going to take it to 4 inches on the shoulder, just reading off the digital readout. Right there, and I'm going to face out. Okay. Now let's check that measurement real good. Yep, right on the money, 985. So we're ready to cut our next step in. We're going into 2.875. I'm going to put my mark. And this measurement goes down to 0.955, so we're pretty close, just a little bit smaller diameter. I'm just going to dial that in, 0.955. Right there. And we'll take it down to that mark. Should be it. fine there. That's good. Okay, so now I need to go into 1.125 right there. And that needs to be cut down to 3/4 of an inch, 0.750. Cut that shoulder out. Then there's a little lead in down here. It goes in 0.375. Right there. And that goes down to, what's that, 0.660. There we go. I'm going to break some corners here. And right here at this little transition, there was a little kind of radius cut down in there that kind of gives a place for that spline to come out. I'm just going to go ahead and kind of plunge this down in there a little bit. Kind of create a similar. And we need to thread that down there on that end to 3/4, what did I say it was, 16? We're going to start. The original kind of has a groove down here in the bottom that goes all the way around that thread cuts down to. And we're going to do the same thing here. That kind of gives me a stopping point for it. Put a little cutting oil on there. Touch off here. We'll make a scratch pass. We'll check our thread pitch. We should be on 16, and that looks like it matches. So let's cut these threads. I do not have a nut to check this with, but I do have a die. So I'm just going to run a die up on it and probably cut that last little bit of thread out of there using a hand die, and that should get it to size. So we'll just get that going here. And, you know, I purposely stopped just a tad bit shy, but tried to get it as close as I could. And I'm just barely cutting threads as I go down through there. but that should be right on size when we get down to the bottom. All right. All right, that should be right on size, and that should have this side all finished out. I'm gonna get my micrometer, just double check all my measurements, but we should be ready to flip this thing over and do the other side. The spline will be cut during this section right here. This is the bearing area where the bearing will sit up on. Well, here we go for side number 2. Again, I've got a little sketch here. Got 3 steps basically to get turned into that. No threads on this end. This one should be a little bit easier. First off, I need to go in here and zero out my, first off I need to get my speed back up where it needs to go. All right, let's touch off on the end. Mark that as 0. And I go in 3.3 inches. There. I'm just going to do about a 60 thousandths first cut, and we'll get our measurement on our digital readout. $190. 1.190, enter, and we're going to 141, so I'll just dial that in. $141, right where we need to be. All right, next one. All right, next one we need to go into 1900 on our depth, which is right about here. Let's see. 1900 right there. Diameter is 0.976. Do this in a couple of passes. Check this with the micrometer. Right there. That goes down to, what is that diameter? 0.913. A 45-degree tool here. I'm just going to break some corners here. Lightly break that front edge. Lightly break that one. This one here gets chamfered all the way down, 45 to the bottom down there. There we go. Well, almost done. Also need to put a little groove in here for the end of that spline like we did on the other one. There we go. Now, I think we got our turning done. There's the old original shaft. Here's the new shaft. Of course, we still got to cut our splines in here, but everything else, and we got to drill a hole down here for a cotter pin. But everything else is pretty much turned out on the lathe. So I got to get some cutters ordered, and we'll get set up to cut those splines. That's going to be coming up in some more videos coming soon. But I think we got this thing, got what I wanted to get done today, which was get this thing roughed out. Well, there we go. Got some lathe work done today. Like I said, when I get these cutters in to cut these splines, we'll get set up to do that, finish this axle out, and hopefully get this job knocked off the list. So there you go. Well, guys, with that is going to be a wrap. As always, thanks so much for watching. Please, please, please subscribe if you have not already. Hit that like button, leave a comment down below. Both of those really help out with the algorithms on YouTube. Also, a big, huge thank you to the guys out there who support the site financially through Patreon and PayPal. There's links for that down in the description below. It really helps out as well. It enables me to take the time to shoot these videos and bring them to you. And with that, we are going to sign off and get out of here, and we will catch you guys on the next video. Again, thanks for watching.